Well, I promised you a video on a modified magnetic amplifier, and here it is. It's not practical, but it does display over unity quite rapidly, in fact. And I'm speculating or presupposing that what Tesla would have called a magnetic amplifier in his day and age is what we call Eric Dollard's LMD module of an analog computer. I believe they're one and the same. Excuse me. um, Even though Tesla did not invent the magnetic amplifier, I think he made judicious use of it because there are there are a lot of variations to the magnetic amplifier. And they usually, at least the ones I've seen, do not include the use of capacitors. Be that as it may, I believe that's the case, or this is the case. So it gives a new twist to history, possibly, that Eric Dollard simply reinvented a wheel that turns very nicely. Now, I've done two versions, and they're slightly different. Usually, when I do a Java version, it's the same as the JavaScript. I originally crafted in JavaScript and then tested in Java, but it didn't behave very well in Java. So what I did was I reduced the henries to 10 nanohenries. The JavaScript version had 100. And I increased the voltage on the battery from 1 microvolt in the JavaScript version to 12 volts DC in the Java version. And I call this Java version Kaboom Magamp. And the JavaScript is Runaway Magamp because it's a little slower as it reaches infinity. And this one we don't even have to close the switch, which kind of makes you wonder, do we really need the battery? Oh, let's try that. I'm intrigued. Let's get rid of the battery and draw some wire and see what happens. Oh, see what I mean? I'm going to have to change this and take out the battery. Oh my god. That's pathetic. So we got all this power, and where did it come from? Now, what we do, if I have this correct, is we edit a component, we click OK, and now we can go over and look at for things. So we got kilowatts on this resistor, and we got, oh my god, what is that? 1,000, a million gigavolts. Let's see, it goes up tera, and then I think the next one is peta. 1 petavolt on this inner capacitor. It changed. What happened? Oh no, that was the resistor. Oh, I see. Oh, this capacitor has the same value of voltage as this. No. Oh, I mixed up what's what here. Well, anyway, you can see they're very... Ooh, there's a big one. I don't even want to guess what that one is. The watts. Oh, the voltage is a little less. So it basically maxes out and well, it maxes out in the sense that we got convergence failure message. And that means the simulator can't handle it. It's just too complicated. Doesn't mean there's anything wrong with the simulation. It just means it's too much for the simulator to handle. I don't think it means that it's too much for the computer to handle. When that happens, the moving display on the oscilloscope tracing window jumps, and you keep trying to lower the simulation speed, and it's never slow enough to eliminate the jumping. So we don't even need a voltage. It's like, where did the power come from? You know? And this is Java, which is supposed to be a little better than JavaScript. Oh well, whatever. Now, when I say that it has 2 LMD modules, what I did was I put one outside the other, but it's really 2 in series that wraps around to the other end. So just imagine this LMD loop here is doubled over here, but I turn it around to this side. And all I have to do to turn it around is put a capacitor on the outside of this loop here. That's all I have to do. Because when you wrap it around to itself, it shares the same transformers here. So these are 10 nanohenries. So let's move on to the JavaScript version. Now here, it will reach infinite wattage on the inductor. No, actually, it reaches it in far less than 1/100th of a second. But the volts and the amps keep climbing until they reach their maximum in less than 1/100th of a second. So let's... Here we actually need the battery. And I have it going very slow. Only at first. So I wanted you to see how it progresses, the numeric values down here. So here's the wattage growing excessively and writing over the voltage and the amps. But it'll go to infinity in a little bit. And I only used 174.97 microamps and 1 microvolt to do all this. Don't you just love JavaScript? It gives you so much freedom. And it's all in the positive direction for the most part. The negative values are quite small. Well, let's speed things up here. It's taking too long. Oh, there. See? It reached infinity. Now, these will continue to rise, but it takes a little long, so let's speed it up slightly. That's very slight. Oh, there. It reached the limit. And so now it just flatlines because it can't go any higher. So that's my little demonstration of a true LMD module, a true LMD analog computer of a magnetic amplifier, or a true magnetic amplifier in the format of Eric Dollard's LMD analog computer. I thought it was possible, and it took me some while to monkey around with the positioning of the connections of the battery, and these 4 connections that come out on the right-hand side here to get over unity. The other 3, there were, I think, 4 permutations, or possible, or combinations, permutations, I don't know, where to put the battery versus where to put these connections here. So I did the best I could, and then I lucked out on the last option when I was about ready to give up. Teach me not to give up. Let's see what else. So these are 1 femtofarad capacitors, 100 nanohenry transformer coils, and then a motor coil here that's comparable to the motor coil in my electric car. It's about half, but a little more than half, but that's pretty close. And I only need to use 1 microvolt to get this going, unlike the Java, which needed 12 volts to get it going. And then it went too far. So, I don't know, that's interesting. Java flaked out on me. So, I will now post this, and you'll get to see it when you watch this video. Catch you later. Oh, and by the way, this is a continuation of my prior video. So let's go see which one that is. And it's called Accelerating Current by Increasing Distance Traveled by Longitudinal Waves Across Their Dielectric. And I say it's a continuation because I came up with both ahas at the same time. Actually, first I came up with this circuit, and then afterwards I came up with this video. And I managed to do both in one day. Isn't that cool? I've been busy. Okay, so that's what it's a continuation of, and if you look in the lower left there, that's the, oh no, that's the, down in here, when I put my cursor over the video image, that's the link, the URL to that video. So I'm not going to click on it though, but I can click on this. So you can see it's a little bigger. And I put in a nice image. Oh yeah, and then I posted it to my blogspot, Spicy Surges. And so I got the YouTube video, and I got the images that I referred to in that video, and this is what I crafted. And these are the links to support the dialogue of that video. Then over here, we had a very interesting discussion, and I responded to the fellow, and I said things a little different, maybe worded than the video, but I just had to respond. So the shortcut to this will be if you click on this, and this is the shortcut up here that narrows in on just this video, or just this post to energetic form. And it's a very interesting post. It pretty much consolidates what I have to say in the video. So I think that completes my topic. So tune in next time for another episode of Happy Surge to you until we meet again. Happy Surge to you. Tra-la, 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 in the melody of Roy Rogers' theme song, closing credits. Happy Surge to you until we meet again. Do, 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 do.